Hi, welcome back to chapter 2. Today we're going to continue on example 2.3. Okay, so in this example, in a balanced three-phase circuit, the voltage VAB is 173.2 and the reference is at 0. So when the degree is at 0, so automatically VAB is the reference. Okay, determine all the voltage, phase voltage and line voltage and the current in a Y connected load having ZL 10 with 20 degrees. Assume the sequence is ABC. Okay, right. So previously we have learned the three golden rules, right? Okay, so the three rules, do you still remember the three rules? Okay, so the three rules, okay, the first rule, we say that the phase voltage, okay, which is VAN, VBN, VCN, okay, has to lag each other with 120 degrees, okay. And then we have a line voltage, VAB, okay, and also has to lag 120 degrees, okay. All right, so that's rule number 1. So we have rule number 2. Okay, in rule number 2, it says that the line voltage, okay, is square root 3 of the phase voltage. Okay, and rule number 3 is the line voltage will always lead phase voltage by 30 degrees. Okay, so you have to remember these three rules. Okay, so by remembering these three rules, you can solve example 2.3. Okay, so let's draw the phasor diagram. Okay, all right. So the phase diagram. So first of all, we will draw the reference voltage. Okay, so the reference voltage this time is VAV because it at 0 degree. And applying rule number 1, we says that VAV, VBC, and VCA is 120 degrees apart. Yeah, that is rule number 1. Okay, so that is VAB, VBC, VCA. Okay, right. So at the corner here, let's write the equation. So you get VAB from the equation. It says that is 173.2 at 0 degree. And you know your VBC, okay, it's the same magnitude, yeah, because it's a balanced system. So now, because we are going that direction, so it's lag. Okay, so now it's negative 120 for BBC, and VCA is the same magnitude again, and this time is 240. Okay, that is for line voltage. Okay, right, so now let's do for phase voltage. Okay, so for phase voltage we have VAN. Okay, and you remember the equation from the previous slide? Okay, so in the previous slide, okay, we say that the second rule say line voltage equal to square root of phase voltage. Okay, so let's apply this to get the phase voltage, yeah, this rule. Okay, so now VAN equals to the V line square root of 3. Okay, so that's the formula. So let's calculate VAN. Okay, so that's the magnitude of the V line, which is 173.2 divided by square root of 3. Okay, so for VAN, okay, remember the rules. Okay, the rule number 3. The rule says that line voltage will lead, okay, phase voltage by 30 degrees. Okay, rule number 3 says line voltage will lead phase voltage by 30 degrees. Okay, so now it means that, okay, so the line voltage, okay, will lead phase voltage by 30 degrees. So we put a note here, line voltage will lead, okay, phase voltage by 30 degrees. Okay, so in the diagram, how does this look like? Okay, means that, okay, the line voltage, okay, oh, sorry, forgot the word lead here. Okay, okay, so it means that the line voltage, which is this one, has to come up first before the phase voltage. Alright, so if you see here now, okay, let's erase this part. Okay, because by now all of you know that there are 120 degrees displaced between each other. Okay, okay, so let's draw the line voltage. So now the line voltage has to be 30 degrees. Okay, 30 degrees from line voltage. Okay, so the phase voltage is VAN is 30 degrees. Okay, so it leads, so it has to be appear first, all right, before VAN. All right, so now, okay, can you see VAN magnitude is slightly shorter than VAB, okay, because this length represent 100 volt and this line represent 173 volt. So that's why they are different. Okay, why this is 100 volt? Because 173.2 divided by square root of 3 is 100. You get 100. So that's why. Okay, so that's why the length of VAN is slightly shorter than the line of VAB. Okay, alright. So make sure that when you draw the phase diagram, okay, the magnitude of the line voltage and the magnitude of the phase voltage are not the same. Okay, so now you can write here, okay, it's 30 minus 30 degree. Okay, so let's continue on for VBN. Again, is 173.2 divided by square root of 3, which you get 100. Okay, so now it's 150. Okay, how do you get 150? Okay, to make it short, negative 30 minus 120. Okay, because they are 120 displaced. So that's how you get negative 150. Okay, so VCN is 173.2 divided by square root of 3. Okay, again, negative 30 minus negative 240. So you get negative 270. 70. Okay, negative 30 minus 240. Okay, all right. So let's draw the phasor diagram for the phase voltage now. Okay, for VBN and VCN. Okay, so again, VBC, okay, rule number 3, VBC has to lead the VBN. Yeah. So that's why VBN appear after VBC, and they are negative 30. Okay, so again, VCA appear before VCN. And again, they are 30 degrees, okay, between each other. Okay, between the line voltage and phase voltage is negative 30. Okay, right. So now you already drawn, okay, the phase diagram. Okay, so let's go back to the question. Okay, you have drawn the line voltage, phase voltage done. So now you need to calculate the current and also draw the phase diagram of the current. Okay, so next, let's calculate of the current. Okay, so you know that by applying the Ohm's law, V equals to IR. Okay, so you can get I by V equals R. Okay, all right. So here we want to calculate, okay, the current, okay, the line, the phase current for each. Okay, so we need to get this information. Okay, all right. So let's calculate IEN first. So you know IEN is because this is a phase current, so VBN divided by Z. Sorry, so this is A. Okay, all right. Okay, so you know that VAN is 100 divided by, you are given Z. Okay, we are given ZL as ZL10. Okay, so 10, and we have 20 degrees here, and 100 with negative 30, right? Okay, from here. So from VA, so this, if I simplify, you will get 10, and this, if you simplify, 50, and VCN, if you simplify, you will get 100, 270. Okay, all right, so let's continue on calculating the IEN. So IN will be 10. Okay, so in this case, negative 30 minus 20, you will get negative 50. So IBN will be the same. 100 divided by 10, you will get 10. Okay, so this time negative 150 minus 20, so you will get 170. So for ICN is also the same, it's 10 Okay, negative 200. Okay, so for ICN is negative 270 minus 20. Okay, then you will get negative 290. Okay, sorry, so it's this part. Okay, all right. Okay, so now you already know the informations of the current. Okay, so let's draw the phase diagram for the currents. Okay, all right. So in this IAN, it says that is negative 50 and is okay. So for the magnitude of the current, okay, it will not be the same as VAN, VAB, yeah. So you can actually draw a separate diagram, okay, if you want. Okay, so this is the phase diagram for the voltage. So this is the phase diagram for the current. Okay, you can say that this is IAN. Okay, you can also draw this way, of course. Okay, of course, if you draw this way, it will not show negative 50, negative 170, or negative 220. Okay, so but if you combine them, okay, then this degree is important. Okay, so let's draw them in the combined together with the voltage. Okay, so here is IAN. Okay, so IN, this represent negative 50. All right, so next is IBN. Okay, is 170 so that is IBN. So that is 170. Okay, let's change the color. Okay, all right. So ICN. ICN. So that is 200. 290, yeah. Okay, so in the exam, what normally I prefer is for you to draw, okay, all the voltage, okay, the line voltage, the phase voltage, and also the current, okay, in one phase diagram. Okay, the reason is why, because now when you draw the current, okay, then it can reflect from the equation negative 50, 170, 290, rather than if you draw separately. So if you draw separately voltage and current, you will not see, okay, the difference in terms of the degree. Okay, so when you combine the voltage and the current together, then you can see that, okay, the importance of the degree. Okay, in here, if you draw them separately, you will not see the importance of the degrees. Okay, all right. So what is very important when you want to answer a question, make sure that you know what is the reference. Okay, is it the line voltage as the reference, or is it the phase voltage as the reference? Okay, so you start from your reference voltage first. Okay, like how we did here, we first start with the reference voltage, then we go to the next, which is the phase voltage. Okay, so once we calculate the phase voltage and we draw the phase diagram, then we start calculating the current based on the Ohm's law. Okay, so that's all for example 2.3.